Hello everyone. In this video, I'm going to present you the process of setting up a simulation for aspirin production using Unisim Design. Right now, we already created new project, and at the time we adding all components required for production on the new list of components. They are acetic anhydride, salicylic acid, acetic acid, and aspirin, which are now available to be used. Then, since vapor-liquid equilibrium isn't necessary for our case, also most suitable for handling non-ideal mixtures in liquid phase reactions, such as esterification, which is the core reaction in aspirin production, ideal gas model, and NRTL model, are chose respectively for fluid package. Aspirin and acetic acid are formed from reaction between acetic anhydride and salicylic acid. This reaction is now added with their stoichiometric coefficients, -1, -1:1:1, and balance is settled. Sign before coefficients marks if components is a reagent or product. As you can see, kinetic of reaction is straightforward, and minimum and maximum temperature for it are 70 and 100 degrees Celsius. Reaction is now added and transferred into reaction set, which is associated with fluid package. This step is quite important because reaction can be added to reactor only with all parameters included. We entered simulation environment and equipment with component streams are entering design scheme. First three stream are for salicylic acid, acetic anhydride, and diluent affecting of homogeneity of inlet stream. Acetylator, reactor carrying out esterification process, and acetic acid with aspirin are obtained. Last two components, following to crystallizer where they met up with stream of solvent, acetic acid, and aspirin crystals are formed. From the outlets of crystallizer leaves reaction mixture of acetic acid and solid crystals of aspirin and stream of diluent goes to recovery unit to be recycled and reused. Reaction mixture at 60 kilopascals separated into liquid and solid phases in centrifuge, and acetic acid directed out from it to recovery unit of solvent and after tank to be used and recycled, while wet aspirin going to last stage before being packed and distributed as product. Last stage is a dryer, with 60 to 80 Celsius degrees, which as a final result lets us dry off any remaining moisture, leaving us with pure aspirin. Finally, let's talk about mass balance and flow rates. For our target yield of 1 ton of aspirin, we've set the flow rate of salicylic acid to 1,380 kilograms and acetic anhydride to 700 kilograms, after all calculations carried out. These numbers are based on the expected losses and inefficiencies during the process. Thank you for attention and see you next time.